right, hi everyone. So today we're going to be talking about loops and stay versus exit conditions. This should actually have been stay versus exit conditions inside of loops. All right, so once again in the Java 8 Fundamentals book, chapter 5 has some descriptions about for and while statements, and I recommend having a look there if you want to get some more background. All right, stay versus exit conditions. So if you've got a for loop, the condition in which you're supposed to execute what's inside of the loop body is in between these two semicolons right here. In a while loop, that stay condition is described by the Boolean expression, and they're both Boolean expressions, right in there in the middle of the parentheses. Okay, so you have parentheses here in the for loop, and in the for loop you've got this counter that goes in here that gets initialized and started there, and it gets updated there. The stay condition is in the middle. In the while loop, the stay condition is right there. There isn't that explicit incrementing of a counter. All right, so the stay repeats. If you achieve the stay condition, if it's true, then you repeat the body, okay, and it will continue to repeat over and over and over again. The loop will go over and over and over and again as long as this or that remain true. Okay, so the output to the Boolean expression, whatever that is, remains true. As soon as it's not true anymore, then you don't do any more looping. You exit outside of that body. This is the loop in here. Okay, as soon as you test it and it comes out false, you go around and you continue on beyond the loop. Okay, so if it's false, then you exit. So let's say, for instance, you've got two Boolean variables. These are like true-false variables. So you've got a variable called p and a variable called q. So the question becomes, when does the loop exit? So it stops repeating the action that's inside of that the body of the loop. So for instance here, while, and you have in the parentheses right here, one variable here called p, another variable there called q, and you've got the logical and that's in between the two. So it says that basically both p and q need to be true in order for the loop to continue. So when does it not become true? Well, under these conditions. So it will be amenable to an exit if p and q is inverted or knotted. Okay? In that condition, then what you end up having is the possibility of an exit, okay, which is the equivalent of not p, not q, ORed together. So that's or, and this right here is and. So when does the loop exit? Okay, in this case, you've got p or q. Okay, so you've got p or q. It exits when you have not p or q, which is the equivalent of saying not p, not q, added together. Okay, so let's consider the following loop. Let's look at an example right here. So what you've got is you've called in the scanner library from before, and you've got an integer called x, and it will take whatever integer input is coming in from the user when the user is typing on the keyboard. Okay, that's what's going to happen here. So we've imported scanner from before. Now, what we've got right here is a loop, and inside this loop we have the condition. Let me see. So it's a while loop. That's the while loop right there from beginning to end. And then inside of the parentheses right here, we have two conditions that are ORed together. So look at this condition right here, and that condition right there. The first condition says this needs to be true if x is greater than or equal to 10. And over here we got a condition about 20. So the first condition says that we want a true result for values that are above 10, 10 and above. And the other one is for conditions that are less than or equal to 20. Like that. Okay, so as long as either the x condition is greater than or equal to 10, or the condition is that x is less than or equal to 20, then we're going to continue doing this. So basically, as long as your x is going to be above 10, or your x is less than 20, this looks bizarre, doesn't it? Something is not quite right. This kind of looks like anything. Any value would be valid here. So would this possibly exit? And the answer is, well, no, it can't exit. Let's look at this a little bit more in depth using sort of logic rules. So this will compile, but it has a logical error. And so another way of looking at it is in terms of the logic behind, the official sort of logic behind the exit condition. So we want to look in terms of the exit condition. So what we want to do is we want to take what's in here and we want to invert it, because the exit condition is when not true for that stay condition. So not and the stay condition, right? So the exit condition is the knotted, so the exit condition is the knotted stay condition. So we knot this. Well, we want to negate the stay condition. To negate the stay condition, what you do is you go not on the first part, not on the second part, and then instead of the or, you change it up to be an and. So that's law of disjunction right there. Okay, so that's what we do right there. But then that is the equivalent of saying 10 is greater than x and, or x needs to be sort of less than 10 and x needs to be more than 20. Let's look at that visually. So x needs to be less than 10. There's 10. And x needs to be greater than 20. X needs to be simultaneously down here and there. That's not going to happen. So 10 greater than x, or x less than 10, and x greater than 20 is false. You can't do that, since there are no number that are both smaller than 10 and larger than 20 at the same time. So the exit condition is being false means that there's effectively no way to exit the loop. This leads to what's referred to as an infinite loop. Okay, so this is an infinite loop. And in the vast majority of cases, infinite loops, like raw infinite loops, are a bad thing. There are certain little exceptions where that's actually a desirable thing. But the vast majority of programming solutions, you should not have raw, straight up, infinite loops that don't have a possibility of exiting, that don't have an exit built in. Okay, so you want to make sure to avoid infinite loops in the vast majority of cases in which you would be dealing with in engineering or computer science. Okay, take care, everyone.